Welcome to Digital Electronics Lecture 3 Part 1. So in this lecture we'll discuss about KMF, how to simplify the function using KMF. Let's start. In previous lecture, the operation of all the basic gates and Boolean algebra was used to describe and analyze circuits that were made up of combination of logic circuits. A combinational circuit has no memory characteristics, so its output depends only on the current value of the input. Two methods will be used for simplification of combinational logic circuits. One method is called Boolean algebra theorem, which is directly depend on the experience and practice, which we already done it in the last lecture. The other method is called Carnot mapping. It is a systematic approach, step-by-step approach. Just look at this simple example. We have given z equals a b prime c prime plus a b prime c plus a b c. If you take the common of a b prime, then c prime plus c and say b c. So c prime plus c is 1. So a prime plus b and a b c. If you take the common of a, then it becomes b prime plus b c. And b prime plus b c, using the previous law, it becomes b prime c. So this is the simplification. So this is the one of the approach how to simplify using the Boolean function. This is another simplification approach. So a b prime c prime a b prime c a b prime c plus a b c. Just take the common of a b prime, then c plus c prime, and a c take the common b prime plus b. So a b prime dot 1, it becomes a b. AC dot 1 becomes AC. Take the common of a b prime plus c. So whatever way you approach, actually you got the final result is the same. This is the second method. Another method is you can set up the truth table. So like for your truth table, so you have 3 inputs, that means 8 combinations 0 to 7, and you have given this 0 1 2 3 3 and last 3, that means 5 6 7 is high, other is low. So that is your output. So if you write the values here, so it becomes a prime b c is high 1, and a b prime c, this is high, a b c prime is high, a b c is high. If you take all of the values, that will be your simplification. So take all of these high values and put it together using the sum expression. So like so write the n term for each case where the output is high, that we already discussed it, and write it using this form. So write the n term for each case where the output is high, and write the sum of products expression of the output. So sum of product means the AND function is writing through the plus sign. So sum of product. So the product is summing together, and another is called product of sum. So we will discuss it the next slide. So this is another expression. Simplify the output expression. So whatever we got it, so we can simplify it using the Boolean expression. We can more simplify it. So I think you also can simplify it from your last lecture's concept. Next part is implement the circuit. So whenever you got the function, we just implement it. So BC plus AC plus AV. So this is your last, the soft form, whatever soft form you got, you need to implement it. So what is SOP actually? So if you look at this example here, so A, B, C plus A prime B, C prime, here A, B, C and A prime B, C prime are called mean terms. So whenever mean terms are put using this plus sign, then it is called sum of product. So each of these sum of product expression consists of two or more AND terms. So this is one AND term, this is one AND term, which are known as min terms. So AND term are known as min term, and that are OR together. So these two are OR together. So each AND term consists of one or more variable individually appear either complemented or uncomplemented form. So it could be complemented or uncomplemented form. So two or more AND term is ORing together. So this is called sum of product. What is product of sum? So it is called two or more OR term. This is OR term. So 1, 2, 3. Two or more OR term, which is called next term. So this term is next term. A plus C plus B prime. This is called next term. A plus C prime. This is called another next term. So two or more OR term. So two or more OR term are AND together, because this one and this one is AND together. Each OR term contain one or more variable in complemented or uncomplemented form. So it could be in complemented or uncomplemented form. So next is K-map. So the Karnaugh map is known as K-map, is a graphical tool used to simplify a logic equation or to convert a truth table to its corresponding logic circuit in a simple orderly process. Like we have given this truth table. So 0 0 is high and 1 1 is high. So that means 0 0 high means A prime B prime is high and A B is high. So your output X equals A prime B prime plus AB. So two or more AND terms are putting through OR term, the plus sign. If you draw the KMF would be like that. So 2 input to the power 2. So 4. So you have 4 in itself. So this is A prime, this is B prime. So that means 0, 1, 2, 3. So if you consider in decimal values, or so you can write it as A, or you can write it as 0, A prime, sorry, so this A prime as 0 and A as 1. This B prime as 0, B as 1. So you can write as A and B this way as well, or you can represent that way. Anyway, so it says 0 0 is 1. So this is your 0 0, because A prime is 0, B prime is 0, and it says 1 1. So A is 1, B is 1 here. This is high. This is the representation. This is called the KMF, two input KMF. So this is basically three input KMF. You have three input, so 8 combinations. So you have given 0 1 2 is high and 6 is high. So just put sum together, this 3 and this one. This is your X. So how you can draw it in the KMF? So this is 3 input KMF. So you have 4 rows, 2 columns, or you may have other way. So 4 column, 2 rows, both is fine. So you can represent this like this: A prime B prime, A prime B, A B, A B prime, or 0 0 0 1 1 0 1 1. So remember, your 1 0 is here, 1 1 is here, because if you look at the 0 and 1 values, so it can change only one bit in Karnaugh map. That's why after 0 0 0 1, so it becomes 1 1 to make the one bit change, then 1 0. So here it is C prime, so it is 0 and 1. So anyway, so you 0 1 2 and 6 is high, so 0 1 2 and 6 is high, other is low. So this is the representation. For looping group of pair, so you have 4 input variable here. This is your truth table is given. So you have 16 units of them, then 4 rows and 4 columns. So it can be represented like that: A prime B prime, A prime B, A B, A B prime. And similarly, C prime, D prime, C prime, D, C, D, C, D prime. Or you can write it as it is 0, 0, 0, 1, 1, 0, 1, 1. Again, 0, 0, 0, 1, 1, 0, 1, 1, something like that. So anyways, we have given 2 and these values, I put them as high, and that is your representation, other is low. So looking group of pair. So if you have given this truth table, so you can make a group. So whenever you are making a group, take maximum even number of 1 or 0. For sum of product, take maximum number of 1. From product of sum, take maximum number of zeros. So here too, so these two make a group. So it becomes like A prime B, then C prime plus A B C prime. So A prime B C prime plus A B C prime. So if you simplify it, it becomes B C prime. Just something like that. So same as it is. So it becomes A prime B C prime plus A prime B C. So simplify A B. So you can put it this way or this way. Either one is same. Looking group of pairs. So you have given, so if you take this one and this one as a group, because you need to take 2 or 4 or 8 even number of ones to make a group. So it becomes A prime B prime C prime and A B prime C prime. Simplify it, B prime C prime. And from this one also it becomes A prime B prime C D plus A prime B prime C D prime. For this one, A B prime C prime D prime, A B prime C D prime. So the summary is looking a pair of adjacent one in a eliminates variable that appears in the complemented and uncomplemented form. Just like here, here is your A and A prime is complemented, that will be cancelled, so it becomes B prime C prime. So here the same thing. You here see D prime is complemented for the first two, so it becomes A prime B prime C, and for the last two your C prime complemented, and it becomes A B prime D prime, something like that. So looking group of 4. So here this 4 is group, this 4 is a group, this 4 is a group. So looking a quad of adjacent one in a K-map eliminates two variables. So like you have A, B, C, D, 4 variables. So it eliminates two variables. Like here it is 3 variable A, B, C. So 2 eliminates, so it becomes 1 variable. 4 variable, 2 eliminates, it becomes 2 variable. 4 variable eliminates 2 variable. If you just look at here, it is only C. If you look at here, it is only AB. If you look at here, it becomes A prime B, AB. Then A prime is cancelled, it becomes B. And from here, C prime cancelled, it becomes D. So BD. This is same thing what we discussed. And if you looking group of 8, so looking an octet of adjacent one in a K-map eliminates 3 variables. So you have A, B, C, D, 3 elements, just 1 is output. 3 elements, 1 is output. If you look at here, it becomes A, B, A prime B. So A prime cancelled, it becomes B, and here all is cancelled. So only B. Same here. All becomes cancelled. A, B, it becomes uh, C prime, D prime cancel, it becomes C prime. Looking group of 8 is same as previous. So here it becomes x equals B prime and x equals D prime. So like if you look at these two, A B prime, it becomes A prime B prime. So your A prime cancel, it becomes B prime, and here all got cancelled, C and D. And if you look at here, A, this all got cancelled. Here it is actually C prime D prime and C D prime. So C prime got cancelled, D prime. So D prime is the output. So looking an octet of adjacent one in a K-map eliminates three variables. That's all. Thank you.